Okay, so what I'd like you to do in this space on your notes is to recap what we talked about imaginary numbers. So imaginary numbers are square roots of negative numbers. Specifically, I is equal to the square root of -1. So I squared equals a -1. And now I'm going to introduce you to what we call a complex number. Complex number have two pieces. The pieces are real and an imaginary part. So this part we call the real part, and this part we call the imaginary part. How can you tell that? Well, the real part is the part of the number that doesn't have an I. The imaginary part has an I. So let me just show you a couple examples of complex numbers. Would be 3 plus 7i. If I ask you what the real part is, you would say 3. If I ask you what the imaginary part is, you would say +7. An example, if I have -4 plus a 5i, 4 would be the real, -4 would be the real piece, and 5 would be the imaginary piece. So that's what a complex number looks like. And next we're going to do some operations with complex numbers. And finally we'll graph complex numbers. So let me hit pause, make sure you got the definitions of a complex number, and then we'll talk about doing operations on complex numbers. So when we have operations of complex numbers, what you want to keep in mind is we want to combine. So if there were any notes that you wanted to write for these operations, the notes that you want to write is we want to combine like terms. Remembering that what like terms are. Like terms are terms that look alike. So taking a look at example 5, I have this complex number and added to another complex number. This is the real piece, and so is this. So they look alike. So let's combine those. -5 plus a -6, or plus a +6 is going to equal 1. And a 7i and a 1i, those should look alike to you. So if we're adding those, we'll combine 7i and 1i to get an 8i. So the rules for adding and subtracting are simply add like terms, or in the case of number 6, we'll subtract like terms. So let's go to that problem. Problem number 6 is, again, look at the first number. We have a complex number. We have a real piece and an imaginary piece. We're subtracting, but again, we have a real piece and an imaginary piece. So what we want to do is combine those like terms. In this case, we're going to combine those, but we're going to subtract. So be careful here. A -4 minus a -2 is going to equal a -2. And a -8i minus a -6. Remember, a minus, change it to a plus. So again, we have a -8i plus a 6i, so that will give us a -2i. Adding and subtracting complex numbers work like that. Multiplying work a little different. So let me show you the example of that. Multiplying, I don't know if you guys see this problem as a binomial times a binomial. So what some students see this as is a FOIL method. Remember how we do FOIL? FOIL says we take our first numbers. So our first numbers would be a -12 28 when we multiply. The outside numbers, how do we multiply a negative 4 times a negative 5? I will get a 20, and we'll put our little I there. Inside numbers, we'll take a negative or a positive 2i times a 7. So 2 times 7 is 14, and we have an I. And then remember in FOIL, the last numbers multiplied together will have a 2i times a negative 5i will give us a negative 10i squared. So this is our first step. Now the second step is what we call a simplify step. So what we want to do when we simplify, that means combine like terms. Right now there's a obvious term that look alike, and those are the middle terms that have some i's in it. So let's do that first step. So that first step would be a negative 28, 20 and 14 add up to 34i. And then we have a 10i squared. And now looking at this right now, it looks like we're finished, but a complex number times a complex number is going to be another complex number. So right now, none of these terms look alike, but if you remember from the first part of the notes, I squared equals something, and an I squared equals a negative 1. So we're going to substitute in what I squared equals and simplify. So we get a negative 28 plus a 34i. In this case, we've got a negative 10 divided by a negative 10. A negative divided by, or a negative times a negative is a positive. Oh, now we have some like terms. These now look alike, so we'll combine those. Final answer is 18 plus 34i. So this problem obviously is a little bit more complicated. Let's talk about your steps. First step is you multiply or FOIL. Once you get that, the next thing you want to do is simplify. And when you simplify, that is combining like terms. And then this is your third step. By always, whenever you see an I squared, you just want to substitute in I squared is always equal to a negative 1. And then once you make that substitution, you'll always have two real pieces that you combine into one real piece. That's the toughest problem. I'd like to do problem number 8 with you. If you want to hit pause and try it on your own and see if you have the right answer, then just fast forward to see if you've got it. So I will FOIL. So I'll take my negative 2 times my 1. So I'll get a negative 2. Negative 2 times a negative 4 will be a plus 8i. Inside is another I. And the last terms this time will be a negative 4i squared. So FOIL first. Second, combine like terms. Third, substitute in what I squared equals. I squared always equals a negative 1. So a negative 1 times a negative 4 is a positive 4. Now combine the real pieces and we get a 2 plus 9i as your final answer. Good luck on your worksheet, and please ask questions.